A network interface is where one endpoint of a socket is created that binds to a specific IP address. Network interfaces are usually built in to TCP/IP devices like switches, routers, and computers, or added as external modules like PCI cards when expansion is required. Devices communicate and connect to other devices on a network through their hardware interfaces. Physically, this takes the form of RJ45 ports connected through cabling such as unshielded twisted pair or transmission media like fiber. Devices also employ software interfaces such as the loopback 127001 or software network interfaces bridging virtual machines to a local area network or network address translation server. Programmatically, Java provides the network interface class for accessing the attributes of and switching between network interfaces. The network interface class's methods are static, and therefore you do not build an instance of the class with new as you would with other classes. Instead, you declare a reference to the class and use the reference to access its static methods. For example, here on the top line, we're making a reference to a network interface class object, but we're not actually instantiating anything. Notice the lack of the keyword new. We're just using the static method getByName to go and find the interface called BGE0. Now contrast that to the line below it where we are instantiating an instance of multicast socket. And also notice the argument passed in the third line where we're building another instance of InetSocketAddress. Okay, so the methods are static for the network interface class object. When we don't use the keyword new, we don't instantiate, we simply use a reference. In addition to the network interface class, Java provides another class known as InetAddress, which can be used to return the properties of an IP address bound to an interface. Here are some network interface and InetAddress methods. GetByInetAddress, which specifies the IP address of an interface. GetByName, which specifies the name of an interface. GetInetAddresses, which returns an enumeration or collection of InetAddress objects. GetInterfaceAddresses, which returns interface address instances. GetNetworkInterfaces, which returns a list of interfaces on a host. GetParent, which returns the parent of an interface if you're on a subinterface. GetSubInterfaces, which returns subinterfaces of a network interface. And isUp, which returns true if the interface is up and false if it is not. In addition to the methods previously mentioned, there is isLoopback, which returns true if the interface is a loopback and false if not. IsPointToPoint, which returns true if the interface is point-to-point and false if not. IsVirtual, which returns true if the interface is virtual and false if not. Supports multicast, which returns true if the interface supports multicast and false if not. GetHardwareAddress, which returns the MAC address or layer 2 address. And GetMTU, which returns the maximum transmission unit. Let's apply all of these new functions, methods, and classes that we've just discovered to a simple project. And the goal of this project will simply be to display a small JFrame showing the IP addressing information on the local host that it's being run on. Okay, so we have some globals here. And these are things that we'll need to procure the information. In this case, we'll need a network interface object. We're going to call it netInt. We're going to need two enumerations. And if you're not familiar with enumerations, they're sort of like vectors or iterators or array list kinds of objects collections. You could even compare them to arrays, although they have additional methods. They're not as primitive. So these two enumerations will be used to, in this case, the first one, hold all the interfaces. So it'll build a collection and hold all of the interfaces available on this host. And then each of those interfaces could have multiple addresses. So the second enumeration will hold the addresses for each one of those interfaces. Again, they're global. We're also going to have interface count and interface number. Interface count will count up the total number of interfaces in our collection when we create it, and we'll use this to set a minimum and maximum range for navigation. We want to be very careful that we don't go past the last object or element in our enumeration, and we also don't want to go before element 0, before the first one. All right, and then interface number, we'll use this. We could start it at the first one. I'm starting it at 12 because that's like my actual interface here. I've been kind of playing around with it, but I'll tell you what, we'll make that 0 because yours will probably be different. And that way it'll just start at the very first. Okay. So those are the globals. Now these are just some GUI globals for the graphical interface. We're going to build a simple interface and it's just going to be a small J frame, and it's going to have labels, lots and lots and lots of J labels, and 3 J buttons. Okay, and so that's what all these are. They're just the text items and boxes where we'll display things. They're all global. So that being described, or now that we've covered that, remember that when you run a Java project, the very first thing that happens is the main method runs. So that means this will happen first. So what's happening here? Well, the class is simply building an instance of itself, sort of pulling itself up by its own bootstraps. So the class is called NetworkInterfaceInfo, and so we're just making a new NetworkInterfaceInfo from main, and that would happen automatically. And there's at least 15 different ways to do this. Some methods would require all the functions being static, or we could have a class outside this class build an instance of it. This is kind of a neat way of doing it because that way only the main method needs to be static, and then the other functions can simply be whatever return type they need and not static. Okay, anyway, so main is called first, all right, and we're building the instance of the class. Now, when we do that, remember, whenever you build a class of object, the constructor gets called. So after this happens, the very next thing is the constructor would get called. And then these functions will be invoked line by line by line. So the very first function that gets invoked is build GUI. And that does, you guessed it, it takes care of putting all of our components together and positioning them and setting the properties for our JFrame so that we can have our small little graphical interface here. And so I'll just go through that real quick. Main window is the JFrame, setting the default close operation, and we're setting the size of the JFrame. And I'm not a big fan of layout managers. I like to use absolute positioning. I know there are severe limitations of that sometimes, and you might want to use card layout or flow layout or something like that. But in this case, I'm using null, no layout manager, so therefore each component I'm going to position the x and the y and set the width and the height with the setBounds function, and that's on every single component. So I'm adding the title, and then the label here for total interfaces and the box where that number will go into. I'm just going to scroll down here. I'm not going to go call through every one of them to save time, but this is just basic GUI code for JLabels and J buttons here. But if you need to, I'll go slow enough. You can pause the video and take a look at it. And you could also, I did this, in the text editor version of NetBeans, but you could also design, you can make this a JFrame form, and then you could use NetBeans' graphical designer, and we've done plenty of videos on that, how to do that, so it's up to you how you want to do it, but this is a real small interface, so it would also be easy to do just in a simple text editor. Anyway, we added all the J labels, and here we're just adding the 3 J buttons here, and setting their color, their properties, their X and their Y position, their width and their height, and so forth. Alright, we get down here and we're adding listeners, and that's because I have to add action listener to my 3 buttons to listen for mouse clicks on the buttons. So that's what that function does, and so that means we jump, we're still inside of build GUI, but we jump from here into here. And we're going to build 3 new action listener instances here. We're going to add action listener to each button. And remember that action listener has an abstract event handler function called action performed, which we have to include, otherwise it would be a syntax error. And so each one of these, that's all it's doing. For the previous button, the next button, and the quit button, we're adding action listener to listen for mouse clicks. And it's going to farm out or map out the event handling to these separate functions here. Again, there's a million ways to do this. This is just kind of the way I like to do it. I guess maybe because it's kind of like in Visual Studio where you have a message map and you can map them. Who knows? It's up to you, but that's all that function does right there. So then what do these functions do? Well, previous and next simply manipulate the value of interface number. And if it's previous, I decrement it, and then I go call display interface info, and we'll take a look at that in a moment. But that takes care of getting all the information and displaying it in the graphical interface. And then if I click the next button, I'm just going to add 1 to it. So this will move it forward to the next interface, and this will move it backward to the previous interface. Now I just need to do a little bit of validating. I have to be careful. If I don't want to go, reach like -1. I don't want to, go before 0. Otherwise it would crash. I'd get an array index out of bounds. error or a null pointer exception. So a little bit of validating there in the if. I have to be careful of that. I also have to be careful, in addition to not going before 0, I don't want to go after the last element in my collection, okay, in my enumeration. And that's what this is. I'm just subtracting 1. And remember, we subtract 1 because whereas we start counting at 1, computers start counting at 0. And so, there's that off by 1 or that fence post issue. So I just want to make sure that, it's less than, and then yes, I'll increment it. But if it's not less than the last element minus 1, I don't want to do that because that would cause a crash. So just a little bit of validating there. And then quit is very straightforward. All it does is set visible defaults and dispose to clean up and free any memory that was being used. Okay, so you've seen the code to build the JFrame, the graphical interface. You've seen the code to add action listener to the buttons. You've seen what happens when we click the buttons. And that really only leaves just 2 more functions for us to go over. And then we can run it and test it and see how it works. Okay, well, actually, I'm not even done with build GUI yet. There's one more line that has to be executed in build GUI. So we set everything up. We positioned it X and Y. We set the width and the height and the color and fonts and so forth. We added action listener to all our buttons, and then finally down here, this actually makes the JFrame appear. Set visible true, and then that makes the JFrame pop up, and we can actually see it. Okay, so now we're done. Only a few more functions to go over. So back to our constructor. This function ended up calling, several other functions, and then when it's done, now we get up to here to get interfaces. And this only has to happen one time. So we're sort of priming the pump, okay, before we display things. And to prime the pump, when I call get interfaces, I need to, basically build a collection or get a collection, and supply that to my enumeration. And these methods, most of them need to be in try and catch blocks, and the type of exception you want to catch is a socket exception. Alternatively, you could, say, throw socket should be uppercase. That's it. You could say throw socket exception and sans the try and the catch if you tried and caught it someplace else. But in this case, I like to do it locally. So that's how I'm handling things locally. Alright, so anyway, we have to prime the pump. So get interfaces. Well, what happens? What is all interfaces? Let's go back up and look at our global. All interfaces is enumeration. And if you're not familiar with that, you can think of it as an iterator, a vector, an array list, or even an array. If you compare it to that, then you'll have an idea of what that object is, what that structure is. So this enumeration here, all interfaces, is there to hold all of the interfaces that are available on this host. And in this case, I've already run the program. There's 57. Different hosts will have different, depending on the software installed. I have like VMware, where I have a bunch of virtual interfaces. I have a LAN interface, cable, and I also have a wireless interface. It depends on the host. Your number of interfaces would be different than mine. But whatever that might be, this enumeration here needs to hold all of them. It needs to build up and hold a collection, just like an array of a certain type of object. Right, so back to our function here, get interfaces, where we're priming the pump. So that represents our enumeration. Think of it like an iterator, think of it like an array list, think of it like an array or vector. And then here we're going to call network interface get network interfaces, and that returns an enumeration. That's why we need the enumeration here to hold the return value or the result of calling this method, this function get network interfaces. So that gets all the interfaces on the host, and now they're stored here. Now, once we do this, I'm also going to set. I need to know how many interfaces I have, and set that to interface count. And the reason is, remember down here, we were talking about how important it was to make sure that if we're clicking the previous button, we don't want to get beyond 0, and if we're clicking the next button, we don't want to go beyond the last element, the last object in the enumeration. Well, we're using interface count for that. So it's very important that we know how many items are in our enumeration. And that's what this second line is for. Okay. So this first line, we just sort of prime the pump, and we store the interfaces here in our enumeration. And then this second line here, we just need to count up how many items there are, how many interfaces. And that way we know, and we can keep the user from crashing the program by going too far either one way or the other if they cycle through the elements. Okay, we just have to try and catch, and then we're done. We prime the pump. And at this point, the very last function, the one we haven't covered yet, is display interface info. And that's just going to take interface number, which we changed, so now it starts out at 0, so it'll start at the very first element, the very first interface in our enumeration. And it's going to display it. And how does it do that? Well, it takes an integer argument, which was just the interface number we pass in. Remember that, as with most code dealing with sockets and datagrams and network programming, you need try and catch blocks. Matter of fact, most I/O processes will also use try and catch blocks. So either you have to do this or you have to throw the exception, whichever way you prefer. I'm choosing try and catch locally in the function. Okay, once we do this, each time that I want to display the information for a particular interface, I again need to go and gather all the interfaces just in case something has changed since the last time I clicked the next or the previous button. So I'm going to go once again and look at all the interfaces on the host. I'll get them and I'll store them in this collection here, this enumeration. And then once I do that, now I want to get a particular interface in that collection. And the way to do that, remember netInt, let's go back up to globals. That was just a network interface class object. Alright, and there's no keyword new there. Remember that it's static, like we said before. So it's really just sort of a reference to a network interface object. But in this case, I'm going to use it to hold the return value of this, which is I'm going to go through my collection, my enumeration, all my interfaces, and I'm going to get a particular element right here with the get method, which is whatever I pass in. So starting out, it'll be 0. But if I click next, it'll be 1, 2, 3, 4, 5, and so forth. And if I click previous, it'll be 5, 4, 3, 2, 1. Okay, so, and then all of that would be returned and stored here. And so this reference here to a network interface object would then hold the position, the interface located at that position in my collection, in my enumeration. And once I have that, I pretty much have the things I need to go through and display all the info. And so we're just going to display the interface count, which is whatever particular interface we happen to be looking at the time. And again, to make it a little bit more user-friendly, I'm just adding 1. You as a programmer, you understand things start at 0. But it makes it a little bit more user-friendly. If we start things at 1, it's more pleasing to the human eye, I guess. So that's all we're doing there. We're going to get the display name and the name. And these are just 2 attributes on the interface, and we'll display it. And we're going to get the MAC address. Right? This is the hardware address. And this is returned in the form of an array of type string. So therefore, you'll notice I'm using toString here and here. We have to convert the data so we can set it on the JLabel. Here I have to use arrays toString because it's returned as an array of type string. So, there's some parsing involved. We have to convert some things here, but I don't think anything is. It's probably nothing you haven't seen before if you've been going through the other videos. Okay, so we get down to here, and now what? Now we're going to get, in this case, I'll put a little white space there. All right, now we're going to get the InetAddresses, okay, and this is on this one single interface that's been selected. So remember there were 2 enumerations. Let me go back up here. This one was all the interfaces on the host, but each interface could have multiple InetAddress objects or internet addresses associated with it. So the second enumeration is going to store a collection of all the possible internet addresses for each interface on the host. And so that's what's happening here. We get InetAddresses, and again that returns an enumeration, and that's for the this particularly selected interface. So in this case 0, but it could be 1, 2, 3, 4, 5 or whatever. In our case right now, the very first time we run it, it'll be 0. It's going to store it in our enumeration here. Right? So now we've built up a collection once again of addresses that go with that single interface. Once we do this, we have a for loop here, and we're just going to make a temporary InetAddress object, and we're going to iterate through or go through our collection here, all of those objects. And basically we just want to get the IP address. We want to fish out the IP address and the host name. That's what we're calling get host address, and we're calling get host name here. And we're going to display that in the appropriate JLabels. Alright, the next few are get the maximum transmission unit. And again, I have to convert that to a string to display it in a JLabel. And then the rest of these are booleans, and so I just did some very simple if-else logic. And you could even convert it to a string if you just wanted to display true or false or something like that. But I wanted to get a little bit more, I don't know, fancy with it, or just, so instead of true and false, I'm going to display up, down, yes, no, whatever. You could do whatever you want there, but these are boolean, so because of that, it's a little bit different in how I set things. I'm just making a temporary string. If it's true, it's up. If it's false, it's down, and then I display it on the J label. Or if it's true, it's yes, and if it's false, it's no. Whatever you want to say there. But all the way down, all those are Boolean. In this case, for is point to point, and is up, and supports multicast, and is loopback, and is virtual. All right, so all of the methods, all the functions that we talked about in the previous slides, you can see them in code now, and you can see how they're being used. Okay, so let's go run the program and see how it works. We'll check the syntax. I'm going to right click over here and we'll run it. Alright, and notice I'm on the loopback here. Right, this is my loopback interface. It doesn't have a MAC address, it's just virtual. And I'm going to click next, and we'll cycle through some of my interfaces here. And I think the actual interface I'm binding an IP to is like 12 or 13. So next, 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 next. Alright, IP version 6, there's a MAC address, hardware address. And here you go. Here's my class B, 172.17.49.91. That's my class B address. And that's my Centrino Advanced, blah, blah, blah. That's the interface name. You can see, it's up, it's active, the maximum transmission unit, multicast yes, loopback no, virtual no. Let me go back. I'm going to click, and we'll go to, alright, so notice if I click previous, it doesn't crash. Now, if it weren't for that if and else, it would crash. So remember, when you're coding it, you have to be careful. You can't go past the first element, or back behind the first element in your collection, in your enumeration, just like in an array. You get a null pointer exception or array index out of bounds. And then also, we click next here, and we'll try to go to the very end. Yes, I have quite a few interfaces on this host, and more than I need. I should delete some of them, but a lot of them were there for VMware and just various virtualization programs and things that I use. And let me go here just to show you multicast settings here, VMware virtual Ethernet adapter. Let me go here all the way to close to 57. All right, 55, 56, and then I want it to stop right here, and that's why I had to have that other if in the event handling code for the next button, because if I were to let the user go beyond that, it would just crash and try to access a null object, array index out of bounds. So hopefully that will give you an idea of some of the pretty useful and interesting features of the network interface class and different methods that you can call from it to to return various pieces of information about an IP address or a host or an interface.